In this video, let's talk about how can we create our own functions, and let's learn a couple of more useful functions. So first of all, if you go to the help, I have opened up one of the functions, which is len, which we have used before, which basically returns the length of an array. So, but you can see there's all of these types of len functions. So you can see that it basically says that whatever information that we're gonna give, we can give it vector, matrix, array, or string attribute. It's basically going to work the same way for each one of these. So basically it's going to pick the right one, the right function for the data type that we actually input. So for us to, and let's check it out. So first of all, let's create a very basic function. So first of all, let's say it's going to be an int function. Let's call it my fun, then brackets, and the distinction for our own function to create is the curly bracket. So I'm going to press enter and create a curly bracket, and everything that we write inside here is going to basically be our function body, and this is our function head. You can see in here we can start writing parameters, something like int equals a or whatever, but let's just keep it very simple. Let's leave it alone, just a basic brackets, and inside let's write int a equals 0, and for our function to work we have to return some type of value from this function. So all I'm gonna do is write in return, and we're gonna return a. So you can see in this function we have basically created int a value, it's 0, and we are returning this value, and that's it. We can now let's print out. So for the print, it's very basic, and let's print out our function my fun, and then in brackets like that. Let's take a look at what we have printed out. You can see it's 0, and if we change our a, you can see we're 2. Now let's go one step above. Let's actually create the int value in our function head. So let's say int, let's say b. So now we have int b, one value. Also you can write in two values. So when you have to separate them by semicolon. So int b and int, actually let's create a float c, like that. So you can see now we have two values, but you can see that it's gonna error out because in my function it says that we still have an empty bracket. So let's introduce our two values. So int first is going to be, let's say, just 3, and for the float is going to be 2.4, like that. So you can see our function still works even though we are not using any of these values inside our function body. It still works because it's just sits there. But we can also reference these two values inside our function. So let's say that our int a right now is 0. Let's say, and now that we have defined a, we do not have to write that it's an integer value. So a equals, let's just say, b plus c, like that. Close it down, and that's it. So you can see now it's fine. You can see our function works, but you can see we have this exclamation mark. Basically says that we use these you to explicitly cast this value, because basically what we did is added to integer float, and then we want to return an integer. Since integer is a whole numbers, we have to explicitly cast this float. So instead of what I want to do is basically just before c in a bracket, basically convert it to the integer value. Just write integer in brackets before the c, and that's it. You can see it's disappeared. We are now basically converting this float value, which is 2.4, to the integer. What we are doing, we are just cutting out the rest of the comma. So for now it's basically 2, even if this float value is going to be 2. Let's say 9, you can see it's still a 5. So it basically cuts out everything after the point value. So if you want to be it's 6, you have to write in 6.0, and now it's 6. Now let's create the same function just like in this example, but only now let's write in two integer values as in our function head. And let's say we still want to return int value. So let's just minimize this. Let's copy all of this function. Let's go in here and let's paste it. So first of all, let's convert these back to the int. Actually, let's create them as a float. And in our other float, let's just do something completely different. So A is still going to be A. So now we are still converting, and so let's just give our float value. Let's return float value so we can know the difference. And the float is now combining of these. So you can see basically we are now what we want to do is return a float value. But you can see that our function is also int value. So let's just give it a float also. So you can see it did not error out. Even though we have functions with the same name, but you can see that we have these our function heads, that the inputs that we need is different. So this is int and float, and this is float and float. But if we, let's say, make it an int now, you can see now it's going to error out. So as long as we are asking for different inputs in our function head, we can have the functions with the same name. And inside them, that can be completely different logic. So in this, let's just say we want to a, b plus c, and let's just multiply it by 2000, like that. Something completely different. So you can see, so and for our printf, you can see we are still printing out our first function with the int and float. All we really have to do is to get our second value. It's going to be automatically selected once we are actually inputting the right numbers. So now we are int and float, and let's just make it 3.0. So now we have float and float. You can see it has converted to the different logic text for two floats, and our two floats is our second function, which is with the same name. It's only with the function head inputs differently. Creating your custom functions is a great way. How can we outsource some logic into functions? So let's just do a simple example. Let's just make it one function now, and let's just delete these two. And our only thing that our function is going to be our random number generator. So first of all, so my fun is going to be with no int or float or values inside our brackets. And here all I have to do is return a random integer value. So let's just put down rand, and let's give it some seed with face of channel, chf. Let's call it rand, like that. Let's put it out into the int. So the int is going to basically our random number from 0 to 1 is going to round up to the whole number, like that. And now let's delete these since we do not have anything inside them, like that. Let's go to our console. Let's create our UI. Now we have our channel, you can see. We are now 0 to 1. And what we can do is also create we can also multiply it by how many, let's say we want to select a random point from it. So before the int, after the rand, what we can do is multiply it by the number of points we have on this geometry. So endpoints and 0, like that. Now you can see we are basically getting a random number between 0 and 362, but technically we do not have point 362 because we take points. Since we use the endpoints, it gives how many points we have, and since the point number starts with 0, it gives basically 362. So for us not to get a 362 point, what we can do is basically subtract 1 from it. So just -1, and remember, make it in brackets, endpoints, and subtract 1 in brackets, like that. So this basically makes sure that we do not get a 362 point. So like that. So in essence, what we have done is basically outsource this kind of randomization out in our function, and we can call it anywhere in our wrangle node. So let's just say I want to randomly color this point red. So what I'm going to do is set point attribute. So 0, let's call it CD. And now what I'm going to do is reference my function. So I'm going to copy it, paste it, and then let's, for the value in curly brackets 1, 0, 0, that's going to be red, like that. And let's find it, you can see, and now if we start randomizing, you can see, basically jumps around, and we are now coloring it basically randomly based off our function. So if we would want to, so let's say I wanted to randomly pick this point, we would have to write this whole thing inside this one small space, but in this place we can basically outsource it on its own function, which is super easily when you're starting to have very long lines of code. We have outsourced it, this kind of logic in this function that we can reference anywhere in our Wrangle node. Now let's talk about a couple more useful functions. So first of all, let's talk about nearpoint, and also very similar to it, nearpoint. So let's start with nearpoint. Basically, it's going to find the closest point to geometry. So at the most basic level, what we have to do is give it geometry that we're going to get a point from, and the vector, basically point in space that we want to get the closest point to. So let's say our point is maybe somewhere on grid here. So give me the closest point to this geometry. So which point is the closest to this one? So for that, let's just start with basically what we can do is reference any of these points. So basically, if we reference point in space in here, the closest point is going to be the same point location. So let's do that. So first of all, let's get our channel that's going to select our point. So like that. So now we have our point selector. And now from this point, we actually want to get our point in space. So for that, what we're going to be is going to get a vector. Since we want to get point in space, it's going to be a vector. Let's call it point location. And that's going to be point function. And point function we have the 0. So if you want to get the p, so it's going to be attribute going to p. Let's take a look at it. And all we have to do is now it's give a point number. And now since you want to get the location of this point, of our point that we just created in here. So that's going to be my point. As a point number, it's going to be my point, like that. And now let's just print it out. You can see now we're basically printing out the location of this point that we are selecting with our UI element, the location of this point on our console. So this is exactly what we want. Now we have everything for our nearpoint function, so let's just use it. Nearpoint, geometry going 0, and then the vector is going to point location. Like that. So basically it's going to give just a int value out of it. So right now it doesn't really give it. So what you can do is actually use this point value in our set point attribute. So I'm gonna copy it, delete it, write set point attribute. So 0, let's color it CD, then the point number, and just gonna paste it inside. So this is, since it's gonna give just an int value, you can just paste the whole function inside the point number that you want to color. And then all I have to do is write in what kind of color. So in curly brackets, I just write 1, 0, 0, and that's it. And let's find it. There's our red point, there it is. So it should be actually 8. So yeah, it's 8. Then it just starts to color it like that. So this is not very. So basically, we could have just pointed this point number just with this channel, but this is just to show how our function works. But what's cool about this, actually, we can introduce our other, let's say, just another point that is not on this geometry. So let's just put down sphere, and by default, it's going to be primitive, and in primitive, there's basically just one point. You see, point, and we can move it around like that. What we're going to do is actually reference this point inside our Wrangle. So let's connect this. Let's just minimize this. Let's connect this sphere to our Wrangle second input. So you can see now it's going to be referenced as 1. So let's reference it as 1. So instead of getting the point location of our sphere that we want to color, let's delete it. Actually, we don't even have to delete. We just have to change the point value that we want to get. So instead of my point, since we know it has only one point, we have to reference it as 0. So we don't want to use this channel, but we want to use just the one point that this sphere has 0. And for the geometry location, since we want to, from this one is going to be referenced as a 1. So 0 is our first point and 1 is our second point, like that. And now let's take a look what this actually does. So you can see, once we move this sphere, our point color is changing the nearest. So we are coloring the nearest point to our sphere that there is. So let's minimize this. You can see it's very visible that we are now influencing our color based off other objects. You can see there's also a couple options what we can do in a function head. So first of all, you can also specify maximum distance, which is basically exactly how it sounds. So let's just write in, let's say 1. You take a look at, so in here, let's move sphere. You can see as long as it's bigger than 1, it's not going to paint in, but as long as distance between the closest point and the point that we want to reference our sphere is smaller than 1, you can see it starts to paint them in, like that. So that's pretty straightforward. So let's just go here and let's delete 1. You see now it's painted in. So and then you can use also the groups, and then groups with the max distance. So it's pretty straightforward. So now let's talk about near points. In near points it's a little bit different, but the idea is the same. So this time we're going to get the array with the point numbers of which is the basically within the range of the max distance. So in this, at the most basic near points function, we denote the geometry, the vector, which is the point in space, and then the max distance. So the bigger the max distance, the more points it's going to select. To see near point function in action, let's just modify our already existing code. Let's just duplicate it. So let's disable set attrib for now. So printf also. So first of all, we still gonna need our vector position because our function needs a vector position for our point to get a near point. So now let's create an array. It's going to be an int array. Remember the square brackets for the array. And now near points. So for our near points, what we need is geometry, so 0. Then we need a location. Our location is going to be our point selector. So that's when we get in here. So point location. Let's copy paste it inside here. And then we need a max distance. And for us to see actually very nicely how it works, let's create a channel, float channel. CHF, and let's call it max dist, like that. And now let's print out our array. So let's copy this, enable printf, and let's print out our array like that. And also I almost forgot to mention that we need to actually change this point location. So since we reference our sphere, so now let's reference one of the points inside the sphere. So let's paint it more back to 0, and then for the point selection, we want to reference our channel, our int channel, like that. So this now we are selecting points. So let's just find our point 1. So this is our point 1, like that. Max distance, let's call it a little bit smaller. Let's go back to printf. Let's clear it. Let's start to increase. So you see now it's basically going to print the closest one, which is our channel 1. And now that we are expanding it, you can see that our point is 1. So in here it's 1. The closest one are 3, 4, 2, 0, 70, 91. You can see it's basically selecting the closest point that next to it, like that. And once we expand it, we are basically at some point going to select all of them, all the points inside our geometry. Also for some variations, you can see there's still a group. We actually can limit the maximal points that we want to select. So let's say I want to select only 5. So let's go back to here and let's just say 5. Like that, and you can see I can increase it as much as I want. So I'm going to pick up the first 5 points. So that's pretty straightforward. And if you want to color also these points that are inside the array, remember to use for each function. So before printing, let's just use for each. For each is basically specified for only arrays, and it's basically whenever you want to process array information, always use for each loop. So for each, first of all we need int. So since our array is int, let's just call it int a, and then reference our array. So basically it asks for the integer value and my array. And then in curly brackets, what we can do is set point attribute. That's going to be 0. So let's cd. So the point number is going to be a. So this is going to be our a point, and then the value is going to be, let's just point it to red, like that. And that's it. Oh, actually, it's just to be a semicolon, like that. So now you can see we are basically looping it around, and every one of these array points are going to be red. Now if we, let's say, change the point that we want to find around, you can see it changes. And let's disable our max distance, max points, like that. Now if we increase, you can see we change the placement of it with point selector, and then what's the difference for our colors. If you're not sure what's happening in this for each loop, it's pretty straightforward. So since our array is holding int information, so whole numbers, that's why we're also creating an int value that's going to store it. So for every loop, it's taking one value out of our array and copies into the a value that we just created. And then this a value can be referenced inside our loop. So now, basically in first loop, it's basically takes the first value of our array, copies in here since we are referencing in here, so a, and then it's because with set point attribute, it's basically painting it red, and then it runs over every point that we want to color it red, like that, and that's it. So that's what's happening in this for each loop, which is basically created just for the arrays, so we can process array data. Another similar function with the nearpoint function is actually neighbors. So there's a neighbor and neighbor. So let's take a look at neighbors since we have already nearpoints. So basically this is going to select every point that has a direct connection with this point that we would select. So let's say we want to get a neighbor of point 11. So you see the direct connection with these are going to be these 12, 7, 17, 10 and 6. So let's try to do it. So it's basically the same thing, only with it little different. So first of all, in near points, let's delete our max distance, so we don't need it. So point location can still be, so we need a point number, not a point, not a vector. So let's disable this one now, and let's just use my point. Let's copy inside here. So now we only need a point, and since you want to know we want to paint in neighbors of 11 in point selector, let's point in 11. So that's that, and let's write in neighbors, like that. You can see we are now painting in all the connected, everything except for the 11. So basically everything that has direct connection with point 11 is now painted in. So now if we change it around with point selector, you can see it creates kind of like star around every one of these points. And for neighbor function, it's going to find only the one neighbor. So first of all, let's go back to the first one. Let's start writing it down. So first of all, it's going to be our int. So let's equals with neighbor. So in this we first have our point number. So our point number is basically in this my point. We have point selector. So first of all, going to be geometry going to be 0, my point. Then let's let's create another one which is going to be our second selector, so neighbor selector. So let's create a channel like that, and that's it. And now let's paint our neighbor. So let's just copy this and copy into the set point attribute as a point. We want to point in our this one. Let's disable printf and vector. We don't really need them, like that. So you see here now. Let's create our UI element. So you can see with this copy neighbor. So first of all, we have point selector 2. So neighbors of 2, which is 1, 4, 5, 29, 28, 0. You can see, and if we change the neighbor, you can see it's basically going to switch between all of these neighbors. Even in help, it actually says that it's going to neighbor num, which is basic neighbor are not in particular order. So basically it's going to just randomize it, which neighbor to color in. You see it jumps around. And even when we go beyond the number of neighbors, you can see it's basically 0. Doesn't paint in anything. So, and if we change the point, we can then point in one of the neighbors next to it. And one last function for today, neighbor count, which is pretty straightforward. We can just actually just print it out right without anything else. So just copy printf, paste inside here. So what we do is just not point selector, but neighbor count. Neighbor count, and then in brackets, so geometry 0, and then the point number, which is, since we are using the same point number inside, so int my point, paste it inside here, and that's it. Now you can see it should be so for our point. So let's select our point, so 9, let's select 9.9. There should be 1, 2, 3, 4, 5, 6 neighbors. Let's take a look what we have printed out. You see it's 6. It says it has 6 neighbors. That's exactly how many that is. It's a very simple, straightforward function in VEX. So that's it for this tutorial. Hope you found something useful in it, and see you next time.